Hi everyone, in this tutorial we are going to talk about eclipsed conformations again and how to identify steric interactions in eclipsed conformations. Eclipsed conformations have atoms and or groups that are eclipsing. Their electron clouds are directly interacting, there is torsional strain, and there are van der Waals repulsion. This direct repulsion and interaction of these groups will lead to these eclipsed conformations having higher energy compared to those with less steric interactions like your staggered conformations, okay? Now, it's important to remember that there are no anti-relationships in eclipsed conformations, okay? And if you were looking at a compound as drawn, and you're viewing it from this direction, if you see that about the carbon-carbon bonds you're looking down, in the plane of the page bonds are in a staple shape, you know you are looking at a snapshot of an eclipsed conformation as opposed to if about the carbon-carbon bond you're in the plane of the page bonds were a lightning bolt, that would be indicative of a staggered conformation. Okay, so here's what I just said. If the in the plane of the page bonds have a staple shape, like this or like this, you know that your perspective drawing is of an eclipsed conformation. So if you look down that bond in a Newman projection, you would see an eclipsed conformation. Here we have three eclipsed conformations, and we're going to talk through the relative steric penalty. What you can do is think about the eclipsed interactions present. Remember, larger groups cause more sterics and have higher penalty eclipsed interactions. Okay? Now, you can really quickly identify the largest steric group on the front and the back carbon. Okay, so that would be the methyl and the ethyl, right? Notice how in the most stable eclipse conformation here, both of those large steric groups are only eclipsing with hydrogens. Remember, hydrogen atoms are the lowest steric penalty atom/group, right? So here we have the most stable eclipse conformation because our large steric groups, the methyl and the ethyl, have very minimal eclipse interactions comparatively to your other two, in which there are interactions where you have here in the middle structure, say the ethyl eclipsing with the bromine and the methyl eclipsing with the chlorine. Okay? Now, this eclipsion of ethyl to bromine and methyl to chlorine isn't as sterically penalizing as having your two largest steric groups, your methyl and your ethyl, eclipsing, because we have the methyl-ethyl eclipsion that makes this far right conformer the highest energy eclipse conformation, okay? And you also have these other eclipsed interactions, the hydrogen-bromine and the chlorine-hydrogen. So again, it's a matter of saying, what are the largest groups and what interactions are they having in each conformation, okay? Really important to consider the relative size of those groups and what interactions they are having with other steric groups in the molecule, okay? Remember, your eclipse conformations will be higher in energy than your staggards. In the last video, we talked about looking at relative energies of staggards. This video here, we've discussed relative steric penalty and how we look at that in a Newman projection of an eclipse conformation.